Hello everyone and welcome to today's video in which I will implement the challenge response algorithm in Python. It will be a very minimal implementation, but I think you'll understand the concept behind it and you can expand it in every which way you want. So we start with the server side. So we're gonna import a bunch of stuff we need for the network connection. So we're gonna import first socket, and we're going to import the rest actually when we need them. So we're going to define the host, which is just the local host, and we're going to define the port. You can use any port really, just make sure it's a number higher than, I think it's like 1600 or something. So we do it like this. And next we're going to write the password. So I'm gonna write the password here, just the password hash, because I don't want to build like an SQL database or some kind of CSV file I have to import and then get the password from, querying for the username. This is something you can do on your own. This is not very complicated. I just want to keep this example here quite minimal. That's why I have here an MD5 hash of, I think this is like PWD. So like the password PWD would result in this MD5 hash. Um, all right. So with that said, let's establish the connection. So we're gonna use this one. We're gonna use it with this with kind of structure in order that we don't have to actually close the connection. So this is just something you need to write. Basically, if you have written a Python server before, you know these commands by heart already, but this is how it goes. So it's S, and then we bind the. So this is a tuple, right? So you need two brackets, host port, and we're gonna listen to any connection. Um, then if somebody connects, we have the connection and the address. Say this accept. And with this connection, we're gonna now communicate with the client. All right, this is so far so good. We're gonna just print really quickly who has connected. So connected by the address. So with this f here, we're gonna tell the print command that there is a variable coming, and we're gonna say while true. So this is like an endless loop which we will break if we don't receive any data. So we're gonna say data is connection. So that's these two things here, like the connection of the client and it's so the client's address. We're gonna say receive 1024 bytes. And if we don't receive any data, then we're gonna just break, and we're gonna just print what we're getting. So in this case, we know it's like we send the username right across, so we're gonna say the user who's trying to log in, so user again with the data we receive. All right, so this is already working, hopefully. So we're gonna just quickly do the client side, and I will just I will just call this uh, server.py. Great. I will copy all of this and we'll make the client. Obviously, I need to change the client code. So let's put this to Python. All right. Yeah, great. Okay. Okay, so the beginning is the same. I need the host I need to connect to, which is localhost, the same port. I do obviously have the same password. I don't bind and I don't listen, of course, but rather I connect. So we're gonna do it like this as connect. So actually, just take this connect to host and port. And actually, I don't think I need any of this. All right, so as connect. So we now connect to the IP address of the server using the port specified, and we're gonna send to this server, we're going to send a byte array. This is very important. Just always use like this B if you want to send a byte array, because then you can just write anything you want in the string, and it will be converted to a byte array. So we're going to send our username, which is of course Security and Privacy Academy, and so we're going to send this, and so this should work already. So we're going to start our server UI. So you can see it here. It's been, so it's listening, and we can see that we've connected. So we have connected from localhost using some port, and we have successfully communicated with the server. Okay, great. Now we have to communicate back to the client, and we're going to do this. So we're now going back to the server. And we now basically what we now would do is like we get the username, and we're going to fetch the password from some database, which is like username, password, let's assume. And we don't need to do this because we already have the password hash here. But this is what you would do in a practical scenario. What we do and what you would also do is like you now create some kind of token. This is going to be the challenge. So the challenge, we're going to say is a random token. So we're going to need actually another library from that. We're going to say from OS import urandom. That will give us a 16-byte random number. Well, it will give us a random number, but a random byte array will specify it to 16 bytes because this is what AES needs. So the Advanced Encryption Standard, which we also, so crypto cipher import AES. And we're going to say we make a variable called object, AES new challenge. So we're going to take this challenge and we're going to make like an AES object out of it. And we're going to choose the mode ECB, which is not really a mode, as you know, but this will, so in practice, you will basically just choose like the counter blockchain mode or some kind of mode, which actually changes the encryption every time you run it. But then you would also like need to send the IV, so the initialization vector over the network, which I just don't want to do right now. So I just use the ECB mode, but the change is really minimal, and it just means that you have to send more variables over the network. But for now, we're going to use this. I'm going to say cipher. So this is basically what we calculate now. We calculate this challenge, and we're gonna encrypt this challenge with the hash, so with the password hash. So we're gonna say object encrypt. So object is now the AES object of this challenge, also of this random byte array, and we're gonna say we encrypt it with our password, which is this hash here, and we actually need to pass a byte array, which is why we write encode. Right, so you can do this ASDF. Now ASDF is a byte array, or if ASDF is a variable, you're gonna say ASDF.encode. Okay, good. Now actually we're gonna send to the connection, right? We're gonna send to the client. We're gonna send the challenge. We do not send the cipher, of course, and we do not send the hash because, I mean, obviously we don't send the hash anyway. But this is the point. The whole point of challenge response is that nothing that is secret is transferred over the network, right? So we only send the challenge. We send a random 16-byte array, which an attacker, a man in the middle, can see if they want to, because they will not be able to calculate the response. Okay, we're going to send this. We're going to go to our client now. And the client will now receive this challenge. So we're going to say S, which is our connection to the server, receive a byte array, and then we're going to calculate the response. And the way we do is we're also going to say object here. We're going to say AES new, so we need to import, of course, AES. So from crypto cipher import AES and news, right? New. So we're gonna use the data we just received, which is the random byte array, which is the challenge. So we're gonna say data, and we're gonna use the same mode. It's very important. You need to use the same mode, so you don't have to use any initialization vectors and so on. So data is the challenge, and our response is now the encryption of this object. So the same thing we did for the server, basically it's the same code. I could have just copied it. So encrypt with our password, which we have here. So otherwise you would just enter it, calculate the hash, and then do this, but we're gonna spare all that because you know how to do this probably, and if you don't know how to do it, please tell me in the comments if you want to know how to actually hash something, how to calculate passwords and stuff. In Python, I'm happy to provide you a code example, but you will probably find plenty of them on YouTube already. So we're gonna encode it again, of course, and we have now this response. And what do you do with the response? You send it back. So you send to the server, we send all the response, which is the challenge, which is the data here, encrypted with our hash. Now, I am the only one who can do this because a man in the middle can obviously catch the data, but he cannot. He doesn't know the hash of my password, right? So we're gonna send the response, and yeah, we're gonna do this now. Here we just have to receive the response, of course. So we're back to the server, and we're gonna say data again, which we can use the same variable, and we're gonna say receive. And for now, we're just gonna print it. Let's say print. We're gonna print. Let's just say received and data. Yeah, that's supposed to be here, I guess. Yeah, that looks good. So just gonna print what we get on the server side. Let's see if it even compiles. Well, it compiles, if it even runs. Okay, let's start the server. Okay, looks good. Well, yeah, okay. As receive, yeah, this looks like a missing equal sign. Yeah, okay. Let's quickly go. Yeah, so the server is still running. Let's connect. Okay, so this is what we received. We received a byte array, and we have these cryptic kind of you know things, and these are just how to. This means hexadecimal, and this is just a hexadecimal number of this byte. All right, so we obviously or apparently we succeeded in sending the response. We can now, so what we now have to do is we have to check whether the response equals the challenge. So we're going to go back to our server now, and we're going to say if data, which is the response, so we should actually say here response maybe. So if response equals the challenge, then we can basically write, you know, we're not writing it, we're going to send it back, we're going to send to the client, we're going to send all, so connection send all, yeah, we're going to just send, I don't know, like logged in or something, logged in. And if not, we're going to send, well, failed or something. All right, looks good. We're going to, actually, we have to break here because, so if we don't get anything, we need to, because otherwise it says connection closed by peer or something, and we need to, and I want to close the connection properly. So if not, response break. Okay, that should do the trick. Received. I actually don't need this, right? No, I don't. Okay, so it looks good. So we're gonna send logged in if response equals challenge, and we just now go to the client and receive this. So we're gonna go here, data. We just copy this, receive, and we're gonna print. We're gonna print what we received. I don't need to be inside the socket here, right? Like this, print. Yeah, we just print the data, I guess. Okay. Let's see how it works. Start the server, connect, boom, failed. Okay, let's see why we failed. And to check this, we actually can, we will look at the, yeah, I'm an idiot, of course. the the encrypted part is, of course, Cypher and not the challenge. So that's obviously stupid. So start the server again, start the client, boom, logged in. All right. Okay, so if you noticed this this mistake before me, then kudos to you. But yeah, this is basically how it works. This is how challenge response works, and the yeah, I'll leave the mistake inside so you can maybe have a laugh at me. But yeah, this is just what happens when you program on the fly. All right. So I hope this makes it clear how to build this. It's obviously a very, very basic example. You would need to have like a database with passwords or with password hashes. You'd have to have like a system where people can actually write something like their passwords inside like a form, and then it gets transferred to a hash. You would need not ECB, so not the electronic codebook mode, but a more sophisticated mode where you actually have an initialization vector. But the principle is the same. And well, I hope you enjoyed the video, and I'll see you in the next video. And write me in the comments if you want it in any more detail, then I'll be happy to provide you with examples. See you in the next.